Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session May-June 2018, Paper 1-2. So let's start with the first question. Question number 1, it is given that y equals to 1 plus tan 3x. Number 1, state the period of y. So the period of the tangent function is 180 degree divides the b value. This is 3, right? So we can do 180 over 3. This is equals to 60 degrees. Or if we do in radians, this is pi by 3. Pi by 3 is 60 degrees. That is a period. Now for the second part, on the axis below, sketch the graph of this function for axis between 0 to 180 degree. Right. Okay, to sketch the tangent function, the first thing is we have to find the intercepts, right? So let me find the y-intercept first. Y-intercept is a point when x is equals to 0, right? So in the curve, put x equals to 0, so y equals to 1 plus tan 3 times 0 is 0, tan 0 is 0, so it is 1. So the y-intercept is equals to 1. Right. Next, let's find the x-intercept. Right. So for x-intercept, let me put y equals to 0. So in this curve, just y equals to 0. So 1 plus tan 3x is equals to 0 and tan 3x is equals to minus 1, and let theta equals to 3x. Right. So from here we can say tan theta is equals to minus 1 and theta equals to tan inverse of 1. This is 45 degrees. Okay, now let me check. Tangent is positive, negative in which quadrant? Okay, A, S, T, C. So in first and third, tangent is positive. It is negative in second and fourth quadrant. So for second quadrant, we do 180 minus theta, and here we do 360 minus theta. Right. So we can say for second quadrant, we have 180 minus 45 degrees. So 180 minus 45, this is 135. And for second quadrant, we have 360 minus 45 degrees. 360 minus 45 is 315. Okay, so the theta, x value, theta is 3 times of x, so it has 3 revolutions. So let me add 360, sorry, adding 360. So we have 2 more values, 135 plus 360. This is 495. And when we have 360, sorry, add 315, 675, sorry. Okay, so if I subtract 360, we can say 135 minus 360, we will get the negative answer. Or 315 minus 360, again the negative one. But as you can see, the domain we have given is the positive ones, right? Okay, now we have the 3 values of theta. We have to check which values lies in the domain. These are the theta values. Now let me find the x values by dividing all the values of theta by 3. So now x is equals to theta dividing by 3. And we have the x value, 135 divides 3, this is 45 degrees, this belongs to the domain. 315 divides 3 is 105, this also belongs to the domain. And 495 divides 3, 165, this belongs to the domain. 675 divides 3, this is 225, this is more. The domain is between 0 to 180, so we are not taking this as an x-intercept. So these are the x-intercepts. Okay, so after the x and the y-intercepts, we have to use the table of values and find out the asymptotes, right? Asymptotes of the tangent function, right? Okay, so if I can take some x and the y values, Okay, so as you can see on the grid, we have given 30, 60, 90, 120, 150, and 180. So let me check on these x values, right? So first we have 30, and then we have 60, 90, 120, 150, and the last is 180, right? So these are x and y. So let me start x with 0, 0, 30, 60, 90, 120, 150, and the last is 180. Right. Now let me find the corresponding y values. The equation we have given is y equals to 1 plus tan 3x. Right. So x equals to 0. 1 plus tan 3 times 0. 0 is just 1. At 30, 3 times 30. This is asymptote, infinite. At 60, 1. At 90, again asymptote. At 120, again 1. At 150, asymptote. And at 180, the last is 180, sorry. This is 1. Okay, now let me draw the asymptotes and x and the y-intercepts on the grid. Okay, so let me label the y-axis first. Okay, so as you can see, this is 1, 2, 3, 4, -1, -2, -3, and -4. Okay, so we have 1 here, right? So the y-intercept you can see is just 1, so we can point this as 1. The x-intercepts are 45, so 45 lies between 60 and 30. 30 plus 60 divides 2, this is 45. So in the middle of the two numbers we have 45. This is the x-intercept, okay, and this is 105. 105 lies between 90 and 120. 90 plus 120 divides 2 is 105. Yes, the middle point. Another x-intercept, and the last x-intercept is 165. 165 is between this. Yes, 150 plus 180 divides 2 is 165. Right, so we have plotted the x and the y-intercepts, and what are the asymptotes? Asymptotes are 30 degree, 90 degree, and 150 degree. Okay, so at 30 we have an asymptote. Let me draw the line. Right, at 90 we have asymptote, and at 150 we have asymptote. Okay, now we have to the rest of the points. So the first point is when x is 0, y is 1. This is already done. When x is 30, this is asymptote, right? So now we have to check that at 1, is it decrease or is it increase before 30? Let me put at 15. So 1 plus tan 3 times x. So if I can check at x 15. So this is 2. So when this is 15, the y value is 2. So it means it is increasing type of curve. This, right? Okay, now the next point at 60, it is 1. So at 60, it is again 1. Let's see. Yes, this is 1 at this point, right? Now we have to check between this asymptote, what is the behavior? The curve look like this or this, right? Which direction the curve increase or decrease? Okay, so if I check between 30 and 60, let me check. And this is the x-intercept, sorry. Yes, we have to connect these points. Yes, we got the hint. Right. At 120, it is again 1. We have an x-intercept. we have a curve, and this is x-intercept, and at 180 it is again 1. You can see at 180 it is 1. So this is 1. Right. So this is a shape of the tane curve. Question number 2. Find the values of k for which the line does not meet the curve. When the line does not meet the curve, it means the discriminant is less than 0. Right. So first we have to put the line and curve equal. 9xk minus 3k plus 1 into x plus 5. This is equals to 1 minus 2kx. Shifting all the terms to the left. 9x square minus 3kx minus x plus 5 minus 1 plus 2kx. This is equals to 0. So 9x square, and we have 2kx minus 3kx. So minus kx minus x plus 4. This is equals to 0, or 9x square minus k plus 1 x plus 4 equals to 0. Now we have to take the discriminant and put it equals to less than 0. Okay, so the discriminant is b square minus 4ac. Right, this is less than 0. So this is a value, this is b, and this is c. So b square is minus k plus 1, its square, minus 4 times the a value times the c value is less than 0. So this is k square plus 2k plus 1, and 4 times 9 times 4 is minus 144, is less than 0. Right. Okay, now k square plus 2k, 144 subtract 1 is 143, minus 143. This is less than 0. Right. Now this is the quadratic equation in k. Let me find the 2k values. Let me factorize this. 1 times minus 143 is negative 143. And if I do 11 times 13 is 143. And 13 minus 11 is 2. K square plus 13k minus 11k minus 143 is less than 0. So k is common. K plus 13 is left. Negative 11 is common. K plus 13 is less than 0. So now the factors are k plus 13 and k minus 11 is less than 0. Okay, so from here we have two k values. K equals to 11 and k equals to negative of 13. Okay, so let me draw the parabola of this curve. Right. So as you can see, the coefficient of k square is positive, so the parabola opens upward, and we have the two roots, 11 and negative of 13. Let's say we have 11 here and negative 13 over here, somewhere here. So if I draw the parabola, it opens over here. So let's say this is negative 13 and this is equals to 11. Right, now we have to find the points when the curve is less than 0, lower point. So it means the curve is less than 0 when the k values are between minus 13 and 11. So we can say that the k is between minus 13 is less than k is less than 11. The line does not meet the curve. Question number 3. The variables x and y are such that when e power y is plotted against x square, a straight line graph passing through the points 5, 3 and 3, 1 is obtained. Find y in terms of x. So we have a straight line. So the equation of straight line is y equals to mx plus c. Now y we have to use e power y, and x we have to use x square, right? So we can say e power y equals to mx square plus c. Now let me substitute the 2 points one by one. So the first point is 5, 3. Okay, so this point is 3, m, this is 5 plus c. Substituting the second point, 3, 1. So we have 1 equals to m3 plus c, right? Now let me find the value for m and c. We have the two linear system of linear equations. Let me subtract the two equations. So negative, negative, and negative. Positive c and negative c is cancelled. 3 minus 1 is 2. And from 5 take away 3 is 2. So 2m. So from here, the m value is equals to 1. So m is 1. Substitute the m value into first or second equation to get c. So we can say 5m plus c equals to 3. So c equals to 3 minus 5 times m. So c equals to 5 minus 3 minus 5 is negative of 2. Okay, now let me put the m and the c value back to our equation of line. So now we have e power y is equals to m is 1, sorry, just x square minus 2. So we have to find y in terms of x, so we have to do natural log on both sides. Natural log of e power y equals to natural log of x square minus 2, right? So we have to shift the y before the natural log. So y natural log of e equals to natural log of x square minus 2, and natural log of e is just 1. So we have y equals to natural log of x square minus 2. So this is the function y in terms of x. Question number 4. A particle P moves so that its displacement x meters from a fixed point O at t seconds is given by this. Number 1, find the value of time when the displacement of the particle is 3 meters. So this is a displacement, right? So at t is equals to 3. No, we need to find the time, right? At x is equals to 3. We have to find the time. So x is 3. This is equals to natural log of 5t plus 3. Okay, now we have to convert the logarithmic form to exponential form. So we have to do e power 3 equals to 5t plus 3. Or we can say 5t is equals to e power 3 minus 3. Or time is equals to e power 3 minus 3 divides 5. Let me simplify this. E power 3 minus 3 divides 5. 3.417, or we can say 3.42. Time is in seconds. Yes, 3.42 seconds. Now for the second part, find the velocity of the particle when time equals to 0. So the velocity of the particle, displacement is given. Velocity is the derivative of displacement with respect to time. So we have to differentiate this. The derivative of natural log is 1 over 4t plus 3, 5t plus 3 into the derivative of 5t plus 3 is just 5, right? So this is 5 over 5t plus 3. Now let me find this at t equals to 0. So when velocity at t equals to 0 is 5 over 3, because 5 times 0 is just 0. 5 by 3 or 1.67. 7 meter per second. Now for the third part, explain why after passing through point O, the velocity p is never negative. Okay, so as you can see, this is a velocity of the particle. The particle velocity is 5 over 5t plus 3. After passing through the fixed point O, the velocity of the particle never be negative, because since time is greater than 0. Time can be 0, 1, 2, 3, 4. It is positive. So when you put a time over here times by 5 plus 3 and then 5 divides that answer, you will get the positive answer, right? So the velocity never be negative. So velocity is greater than 0. Now for point 4, find the acceleration of the particle at time equals to 0. So the acceleration of the particle is the derivative of velocity with respect to time. Okay, so this is the velocity we have. So differentiate this velocity with respect to time. So as you can see, we have 5. This power is in the denominator. We have 5t plus 3 power minus 1. So we have to differentiate this d by dt. right? So the acceleration is 5 is outside. We have to use a power rule over here. So we have 5t plus 3 minus 2, and this minus 1 as well, and the derivative is 5. So this is 5 times 5 is minus 25, divides we have 5t plus 3 whole square. Okay, so this is acceleration of the particle, and we have to find at time equals to 0. So we can say at t is equals to 0, what is the acceleration? Acceleration is minus 25, divide 5 times 0 is 0, plus 3 square is equals to 9. So this is negative 25 over 9, or if I convert it into decimals, we have negative 25 divides 9 is 2.78 minus 2.78 meter per second scale. Question number 5, part 1. The first 3 terms in the expansion of this can be written as this. Find the values of each of the constants a, b, and c. So we have to open this by using the binomial expansion formula. So we can say that the first term power 5 plus 5c1, the first term power reducing by 1, that is 4, and the second term power is 1. The first 3 terms we have to find. The first term, second term, and the third term is 5c2. 3 power is 5, 4, and now it's 3, and minus 1 over 9x. Its power is 2, right? So 3 exponent 5 is 243 plus 5c1 is 5 times 3 power 4 is 81 times minus 1 over 9x plus 5c2 is 10. 3 cube 27. Negative 1 square is just 1. 9 square is 81, and x square. Okay, so 243. Now let me simplify this. 5 times 81 divides 9 is negative 45 divides x, right? And the last term is 10 times 27 divides 81. This is 10 by 3 x square plus 10 divides 3 x square, right? So this can be written as a value is 243 plus b over x, b is minus 45 plus c over x square, and c is 10 by 3, right? So let me write down the values of a, b, c. A is equals to 243, b is minus 45, and c is 10 by 3. Right, now for the second part, use your values of a, b, and c. Find the term independent of x in the expansion of this, right? Okay, so the term that is independent of x is basically the constant term. Okay, we have the first 3 terms of this from the first part. So let me write this down. 243 minus 45 over x plus 10 over 3 x square, and its product with 2 plus 9x whole square. So 2 square is 4 plus 9 square is 81x square plus 2ab. So 2 times 2 times 9, this is 36x. 36x. Let me do the product, and we have to find the constant term. Okay, so 243 times 4. This is a constant term. 243, this is x square term, this is x term. This is 1 by x term, this is x term, and this is just the constant term, yes. Minus 45 over x is multiplying by 36x. This is 1 over x square term, this is a constant term, plus 10 over 3x square is multiplying with 81x square, right? And then this is 1 by x term. So these are the constant terms, right? Let me simplify now. 243 times 4, 972. Okay, and now we can easily cancel x with x and this x cube with x cube. Right, so 45 times 36, 1620. Sorry, negative sign. Okay, and the last is 10 by 3 times 81. This is 270. Okay, so the constant term is 972 minus 1620 plus 270. This is minus 378. Negative 378. This is a constant term, that is a term independent of x. Question number 6. Find the coordinates of the stationary points of the curve. So the coordinates of the stationary point, it means we have to find the gradient of a curve and put it equals to 0. We will get the x coordinate, and putting the x coordinate back to the curve, we will get the y coordinate, right? So let me find the gradient. So the derivative we can do. So we can say dy over dx. This here we have to apply the quotient rule, right? Okay, because there is a product of the the quotient of the two functions. Okay, so in the quotient rule we can say, right, so the denominator scale, the denominator function, it's scale, the denominator function, the derivative of the numerator function, its derivative is just 2x plus x plus 1 derivative is just 1, minus the numerator function x plus 2 and the derivative of the denominator function. So we have to use a power rule over here. So the power rule is 1 divides 2 and the square root of 2x minus 1. First we need to write down the power, that is 1 by 2, and then the base function 2x minus 1, its power minus 1. 1 by 2 minus 1 is negative 1 by 2, that is why I divided in the denominator, and the derivative of 2x minus 1 is just 2. So we can cancel these 2's. Okay, now we have a square root of 2x minus 1, and then subtract x plus 2 divides with the square root of 2x minus 1, right? And this is whole divided by 2x minus 1. Okay, further simplification, if I can take the LCM, so this is 2x minus 1, right, minus x plus 2, and this is dividing by the product of these two, 2x minus 1 and the square root of 2x minus 1. So as you can see, the bases are same, we can add the powers. Its power is 1 and its power is 1 by 2. So when you add 1 plus 1 by 2, this is 3 by 2. Yes, in the denominator the power is 3 by 2. So dy over dx is equals to 2x minus 1 minus x minus 2 divides 2x minus 1, power is 3 by 2. Okay, now 2x minus x is just x, minus 3 divides 2x minus 1, its power is 3 by 2, right? Now for the stationary points, we have to put the derivative equals to 0, right? So the derivative is equals to 0, so x minus 3 divides 2x minus 1, power is 3 by 2, is equals to 0. The denominator multiplying by 0 is just 0, so we can say x minus 3 is equals to 0. So from here the x coordinate is equals to 3. Now we got the x coordinate, we can substitute it into the curve to get the y coordinate. This is a y coordinate here. So y equals to x plus 2 divides square root of 2x minus 1. So x is equals to 3. So 3 plus 2 divides square root of 2 times 3 minus 1, right? So 3 plus 2 is 5, divides 2 times 3 is 6, and 6 minus 1 is square root of 5. So this is a y coordinate, 5 square root of 5. So we can say that the coordinate of the stationary points, coordinates of stationary points are, we have x, y coordinates. X is equals to 3 and y equals to, or we can say 5 over square root of 5. This is also equals to square root of 5, or you can keep it as it is or in the decimals, that's fine. Question number 7. A population B of a particular bacterium T hours after measurement begin is given by this. Number 1, find the value of B when time equals to 0. So B equals to 1000. E power 0 by 4 is just e power 0 and e power 0 is just 1. So this is the initial population, that is 1000, right? Okay, now for second, find the time taken for B to double in size. So initially B is 1000. So double in size, it means now the B is 1000 times 2. This is 2000, right? So put B equals to 2000. So we have 2000 equals to 1000 e power t by 4, right? So 2000 divides 1000 equals to e power t by 4. So let me simplify. 2000 divides 1000 is just 2. So we can say 2 is equals to e power t by 4. Now taking natural log on both sides, natural log of 2 equals to t by 4 natural log of e. Natural log of e is just 1. So from here t by 4 is equals to natural log of 2, or t is equals to 4 times natural log of 2. So let me find the time taken. So natural log of 2 times 4, time is equals to 2.77. Yes, 2.77 hours. Time is in hours, right? Now for part 3, find the value of B when time is 8. Okay, so we have to find B at e equals to 8. So 1000 e power 8 by 4. So B equals to 1000 e power 4 times 2 is 8. Okay, so e power 2 times 1000, this is equals to 7389.0. B equals to 7389 point, okay, just that's it, 0.0. This is a population when time is 8. Question number 8, part A, solve this equation for theta is between 0 degree to 180 degree. Okay, so we have cos square theta, this is 1 minus sine square theta. So 3 times 1 minus sine square theta plus 4 sine theta minus 4 equals to 0, right? So 3 minus 3 sine square theta plus 4 sine theta minus 4 is equals to 0. Okay, arranging the terms, negative 3 sine square theta plus 4 sine theta minus 1, because 3 minus 4 is minus 1 equals to 0. Taking negative sign common throughout the equation. So this is 3 sine square theta minus 4 sine theta and plus 1, this is equals to 0, right? 3 times 1 is 3 and minus 3 minus 1 is minus 4, right? Factorize it. So 3 sine theta, sine square theta minus 3 sine theta minus sine theta plus 1 is equals to 0. Okay, let me take 3 sine theta common. We have sine theta minus 1, and let me take negative 1 common, sine theta minus 1. So the two factors are sine theta minus 1 and 3 sine theta minus 1 equals to 0. Now let me put both the factors separately equals to 0. So we have sine theta is equals to 1, and the other factor we have sine theta is equals to 1 by 3. Right, let me solve for theta first. So what is theta? Sine inverse of 1. This is in degrees. My calculator is already in degrees, right? Sine inverse of 1. This is 90 degrees, and sine inverse of 1 by 3, 19.47. Theta equals to 19.47 degrees. Okay, now let me draw the coordinates. So let me check on which quadrant sign is positive, because in both equations sign is positive. So sign is positive in the first quadrant and in the second quadrant. So as you can see, 90 lies in the first and 19.47 also lies in the first. So now we have to find for the second quadrant, and here we have to use operation 180 degree minus the theta value, right? So what is the theta value over here? Theta value over here is 180 minus 90. This is 90 degrees. And from here 180 minus 19.47, 160.53 degrees, right? So the values of theta are 90, 19.47 and 160.53, right? Now for the part B, solve this equation for phi is between minus pi by 2 and plus pi by 2 radians. Okay, so if I can say sine 2 phi divides, shifting this, cos 2 phi equals to square root of 3, and sine by cos is tangent, so this is tan 2 phi. Okay, now let me suppose that theta equals to 2 phi, right? So from here we have tan theta is equals to square root of 3 and theta equals to tangent inverse of square root of 3, right? Let me simplify. Tangent, okay, this is in radians. Now let me convert my calculator into radians. Tangent inverse of square root of 3, pi by 3. So theta equals to pi by 3. Okay, now as you can see, the tangent is positive. So tangent is positive in first and the third quadrant. So in the third we can do operation 180 degree plus theta, or 180 is basically pi plus theta, right? So this is for the first quadrant, and for the third quadrant, what is the value of theta? That is 180. We can say pi plus answer 4 pi by 3, right? Okay, since there are 2 revolutions for phi, so let me add and subtract 2 pi. So when we add 2 pi in both values, we have in 1 by 3, adding 2 is 7 pi by 3. And in 4 by 3, add 2 is 10 pi by 3. And subtracting 2 pi, 1 by 3 subtract 2 is minus 5 pi by 3. And 4 by 3 subtract 2 is minus 2 pi by 3. Okay, now these are all the values for theta, 1 2 3 4 5 6. Now let me find the values of phi, because phi equals to, theta is 2 phi and phi is theta by 2. So what is the phi value? Dividing all the values by 2. So first is 1 by 3 dividing by 2, pi by 6 and pi by 6. Okay, the second pi by 6 you can see lies between the given range, right? Minus pi by 2 to plus pi by 2, the given domain that we have given, right? Now 4 pi by 3, 4 by 3 divides 2 is 2 pi by 3, right? 2 pi over 3 is that lies 2 by 3 times 180. This is 120, 120 is more, so this is not in the given domain. This value is not in the domain, right? Now let me check for the next. 7 by 3 divides 2 is 7 pi by 6 and times 180, 120. No, this is again not in the given range. Okay, 10 by 3 divides 2, 5 pi by 3 times 180. No, this is again not in the given range. Okay, so minus 5 divides 3, dividing by 2, so minus 5 pi by 6. And if I times it by 180, this is minus 150. This is also not in the given domain. minus 2 by 3 divides 2 is pi by minus pi by 3 and times by 180. This is negative 60. This belongs to minus 90 to plus 90. Yes, minus pi by 3. Minus pi by 3. So we can say that the only values of phi is pi by 6 and minus pi by 3. That belongs to the domain. It lies between minus pi by 2 and plus pi by 2. Question number 9, part A, 1. Solve log x equals to 3. So converting logarithmic equation to exponential, this is 10 exponent 3 and this is equals to 1000. Number 2, write this as a single logarithm. Okay, so we have log a minus log b square. So this 3 is basically log base 10 power 3, right? So these all have basis 10, right? So this is log a minus log b square plus log of 1000, right? So as a single logarithm, we can say we have to apply log of, here we have a subtraction, so we have a over b square, right? And we have 1000, so we have to times by 1000, or we can say log of 1000 a over b square as a single logarithm. Now for part B, we have to solve this equation. We have to find the value for x, right? So let me multiply all the terms by x. So x times x is x square minus 5x plus 6 equals to 0. Factorize it. Okay, 1 times 6 is 6 and 2 times 3 is 6. X square minus 2x minus 3x plus 6 equals to 0. X is common, x minus 2. Negative 3 is common, x minus 2. This is equals to 0. So the factors are x minus 2 and x minus 3. This is equals to 0. So from here x is equals to 2 and x is equals to 3. These are the two solutions of the equation. Now for the second part, hence showing all your working, find the values of a such that we have this equation. So we have to solve for a. So we have to use a change of base formula here. So we can say log 4a minus 5 plus 6, applying change of base formula here, log 4 divides log a with a base 4. This is equals to 0. Log 4 is just 1, right? Log 4a minus 5 plus 6 into 1 over log 4a equals to 0, right? Okay, now as you can see, this look like exactly the same we did in the first part of B, x minus 5 plus 6 over x. So the x is log 4a minus 5 plus 6 over x equals to 0, right? So if we compare it with the first one, we have the two values. Let x is equals to log 4a, right? So we have x minus 5 plus 6 over x. This is equals to 0 if I compare with this one, right? And here we have two values of x is equals to 2 and 3, right? So let me solve. X is equals to 2 and x is equals to 3. So x is log 4a, this is equals to 2, and log 4a equals to 3. So here a equals to 4 exponent 2 and here a equals to 4 exponent 3. Okay, so a equals to 4 square is 16 and 4 cube is 64. Right. Question number 10. Do not use a calculator in this question. All lengths in this question are in centimeter. The diagram shows the triangle ABC where AB is given, BC is given, and the angle ABC is 60. It is known that sine 60, cos 60, and tan 60. Number 1. Find the exact value of AC. So we have the sides and the angle between them. Here we have to use a law of cosine, right? To find AC, law of cosine, right? So AC is AC square. This is equals to this side square, 4 square root of 3 minus 5, its whole square, plus 4 square root of 3 plus 5 whole square minus 2 times 4 square root of 3 plus 5 times 4 square root of 3 minus 5 and cos of the angle between them, that is 60 degree, right? So further simplification, AC square, this is equals to, let me open the squares as well. Okay, so we have 4 square root of 3 minus 5, or let me keep this as it is in this step, we can do it in the next one. Okay, so here you can see we have 2, this is a plus b and a minus b, so 4 square, this is 4 square root of 3 whole square minus 5 whole square, a square minus b square, and cos of 60 is 1 by 2 times by 1 by 2. We can cancel the 2. Now let me open the squares, right? So AC square is equals to 4 square is 16 and square root of 3 square is just 3, and 16 times 3 is, let me do here, 16 times 3, 3 times 6 is 18, 3 times 1 is 3, and 4, 48. So the first term is 48 plus 5 squared is 25 minus 2ab minus 2, 4 times 5 is 20, and 20 times 2 is 40, 40 square root of 3, right? Okay, now plus, again the square of this is 48 plus 25 and plus 40 square root of 3. 4 square is 16, the square is 48, yes, minus, okay, so a square minus b square, right? Okay, so this is minus 48 and negative times negative is positive 25, right? Okay, so 48 and minus 48, this is positive and negative. Okay, what is left? Now AC square, we have 25 plus 25 plus 25 plus 48. Okay, so 25 plus 25 is 50 plus 48 plus 25. So let me add 50, 48 and 25. 8, 9, 10, 11, 12, 13, 1 and 3, 5, 6, 7, 8, 9, 10, 11, 12, 123. So this is 1, 2 and 3, right? So the exact value of AC is square root of 123, right? Now for the second part, hence show that the cosine of angle ACB is this, where B and Q are integers ACB. So first let me work on the angle ACB. So we have A, C and B. This angle we have to find. Let's say this is theta and this side AC is 123 square root, right? Okay, so we have to find this angle and the front side, this angle and this side. Let me use law of sine here. Okay, law of sine, right? Okay, so we can say that sine theta over the front side, sine theta, the theta is angle ACB, and the front side is 4 square root of 3 minus 5. This is equals to sine 60 over its front side. Sine 60 divides square root of 123. Sorry, this is 60. Okay, so we know that sine 60 is square root of 3 by 2. Okay, so what is sine theta? Sine theta is equals to 4 square root of 3 minus 5 whole divides square root of 123, and this is sine 60 is square root of 3 by 2 divided by 2, right? Okay, so we have to find the value of theta. Okay, so this is sine theta, right? And we have to find cosecant of theta. We know that cosecant theta is the reciprocal of sine theta. 1 over sine theta is cosecant theta, right? So we have to do the reciprocal to get the cosecant. So from here, the cosecant theta is the reciprocal of this expression. So we have to do 2 square root of 123 divides square root of 3 times 4 square root of 3 minus 5. Okay. Now we have to rationalize with the conjugate of the denominator. So this is 4 square root of 3 plus 5 multiplying and dividing by 4 square root of 3 plus 5. Right. Okay, so cosecant theta. So let me compare this with the given one. 2 square root of p, this is 123. 4 square root of 3 plus 5. The numerator is okay. We have to work on the denominator, that must be just q. Okay, so 2 square root of 123 divides, we have square root of 3 and a square minus b square. Again we have to use 4 square is 16 times 3, we have 48, negative 25, and here we have 4 square root of 3 plus 5. Right, so from 48 take away 25, what is the answer? 48 subtract 25, 8 take away 5, we have 3 and 2, 23. So cosecant theta is 2 square root of 123 divide square root of 3, we have 23 here, and 4 square root of 3 plus 5. Again let me compare with the given one. 2 square root of p and then 4 square root of 3 plus 5 is same. We have q in the denominator, the constant, not the square root. So it means we have to open this square root, right? Okay, let me take the LCM for this number, 123. Okay, so 123, let me start with 2. 2 times, no, we can't do with 2. We can do at 3, yes. 3 times 4 is 12, 3 times 1 is 3, and then we have 41. So we can say 41 times 1 is 41, right? So cosecant theta is 2, this is square root of 3, and times square root of 41 over square root of 3 times 23, and this expression 4 square root of 3 plus 5. Now we can easily cancel square root of 3 with the square root of 3, right? And we are left with cosecant theta is 2 square root of 41. This is a p value over the q value is 23 into 4 square root of 3 plus 5. Right, so p and q are integers, 41 and 23. Question number 11. The diagram shows the graph of the curve. Graph of this curve. The curve meets the y-axis at point A. So if it meets the y-axis, it means x is equals to 0. So when x is equals to 0 over here, what is y equals to e power 0 plus 3 divides 8. E power 0 is 1. 1 plus 3 divides 8. This is equals to 4 by 8, and 4 by 8 is 1 by 2. So the y coordinate is 1 by 2. So the coordinates of a, x is equals to 0 and the y is 1 by 2. Right. Okay. The normal to the curve at point A meets the x-axis at point B. The normal to this curve. So we have to find the equation of normal of this curve. At point A, it meets the x-axis at point B. So first let me find the equation of normal. Right. Okay. So equation of normal. Let's do this question step by step. Equation of normal is y minus y naught equals to 1 negative 1 over m into x minus x naught. Okay, so what is x naught and y naught? So x naught and y naught is the point, because they said the equation of normal to the curve at A. So the point A. So this is equals to 0 and 1 by 2. Right, and what is m? M is the gradient of this curve at x is equals to 0, right? So let me do the gradient first. So we have to find m. This is dy over dx, right? So this gradient 1 by 8 is outside. The gradient of e power 4x is e power 4x times by 4, and the 3 derivative is just 0. So 4 times 2 is 8, so e power 4x divides 2. So at x is equals to 0, e power 0 is 1, so this is 1 by 2, right? So now we have equation of normal. Let me find out the equation of normal. So now the equation of normal we have is y minus y naught is 1 by 2 is equals to negative 1 over m. So 1 by m is 1 over 1 by 2. So this is just negative 2. X minus x naught is equals to 0, right? So what is y? Y minus 1 by 2 is equals to negative 2x, and y equals to minus 2x plus 1 by 2. So the straight line, this equation of line AB is this line is y equals to minus 2x plus 1 by 2, and you can see the y-intercept is 1 by 2, right? And the next part of the question says the equation of normal, the normal to the curve at A meets the x-axis at point B. So it meets the x-axis, so means the y-coordinate is equals to 0, right? So we have to find the coordinates of B. Coordinates of B. So at B, x is equals to 0. So y is equals to minus 2 times 0 plus 1 by 2. So here the y is equals to 1 by 2. So the coordinates of B, x is xy. X is equals to 0 and the y is 1 by 2. Right. So the B coordinates are, yeah, I did the mistake. You have to put y equals to 0. Sorry, I did x equals to 0. Okay, let me do it again. So when y equals to 0, so what is x? Minus 2x plus 1 by 2 is equals to 0. So here we have 2x is equals to 1 by 2, and here x is equals to 1 by 4, and the y coordinate is 0. Sorry, 1 by 4, and we have 0, right? Okay, the next part of the question says find the area of the shaded region enclosed by the curve and the area of the shaded region that is enclosed by the curve, the line AB, and the line through B that parallel to y-axis. Give your answer in the form of E over A, where A is a constant. You must show your working. Okay, so we have to find basically now the area of the shaded region, right? Now we have a curve and we have a line and the coordinates of AB, right? So what we have to do, let me find the area under this curve. So we have to integrate this curve between x equals to 0 to x equals to 1 by 4, and we will get the whole area, right? But this portion is not shaded, so we have to subtract the area of the triangle. This is a triangle AOB. The base is 0 to 1 by 4. 1 by 4 is a base and the height is 1 by 2, right? So let's do it. Now the shaded area is area under the curve between 0 to 1 by 4, 0 to 1 by 4, and the curve is this. This is e power 4x plus 3 divides 8 with respect to x minus area of a triangle. Triangle is, this is a triangle AOB. Base is 1 by 4 and the height is 1 by 2. So the area of a triangle is half base times height, right? Now let me simplify this. Okay, so let me take 1 by 8 outside. The integration of e power 4x is e power 4x divides 4, and the integration of 3 is 3x. 0 to 1 by 4 minus 2 times 2 is 4, 4 times 4 is 16, 1 over 16. So this is 1 by 8, substituting the limits upper and the lower one. So e power 4, 1 by 4 divides 4 plus 3 into 1 by 4. This is upper limit minus 1 by 8. We have to do the lower limit, e power 0 by 4 plus 3 times of 0, negative 1 over 16, right? Okay, now for the simplification, 1 by 8, 4 is cancelled with 4. The answer is e by 4 plus 3 by 4 minus 1 by 8 here e power 0 is 1 by 4, and 3 times 0 is 0, minus 1 over 16. Right, open the brackets. We have e over 4 times 8 is 32, plus 3 over 32 minus 1 over 32 minus 1 over 16. So this is, let me simplify the fractions. 3 divides 32, and minus 1 divides 32, and minus 1 divides 16. This is 0, so we can cancel them out. So e by 32 is the answer, and we have to find the answer in this form. E by a, and a is a constant, so the a value is 32. So that is a shaded area. Question number 12, do not use a calculator in this question. Part A, we have given that this is equals to this. Find the value of each of the constant P and Q. So first we have to simplify this. This is in the powers of 2 and the powers of 3. Okay, so 6 is 2 times 3, and its power is P, times 8 is 2 cube, and its power is P plus 2, times 3 power is Q. Shifting 9 to the numerator, 9 is 3 square, and its power is minus 2Q minus 3. So negative, we have to put the bracket. Okay, simplify. So 2 power P times 3 power P times 2 power 3P plus 3 times 2 is 6 times 3 power Q times 3 power minus 2 times 2 is minus 4PQ, and negative times negative is positive. 2 times 3 is 6. Okay, when the bases are same, we can add the powers. So let me add the powers of 2 first. So P plus 3P plus 6, yeah, this is 2, times the 3 powers are P plus Q, and minus 4P minus 4Q plus 6. Right, so this is 2, this power is 4P plus 6 times 3, this power is P minus 3Q plus 6. Right, so we have given that this expression can be written in this form: 2 power 7 and 3 power 4. This is 2 power 7 times 3 power 4. Yes, so we can compare. This power is equals to 7. Comparing the powers, we can find P and Q. So 4P plus 6, this is equals to 7. So we can solve for P. So 4P is equals to 7 minus 6, this is equals to 1, and from here P equals to 1 by 4. Right, and let me solve for Q. So we can say P minus 3Q plus 6 equals to 4. So P is 1 by 4. So minus 3Q equals to 4 minus 6 minus P. This is 1 by 4. Let me simplify. Sorry, we are not allowed to use a calculator here. Okay, so minus 3Q is equals to negative 2, negative 1 by 4. 4 times 2 is 8, and a minus 8 minus 1 is minus 9 by 4. Or we can say dividing by 3. Negative sign is cancelled with a negative, so Q equals to 9 over 3 times 4. 3 times 1 is 3, 3 times 3 is 9, so this is 3 by 4. Okay, so let me write this down here. P is 1 by 4, and the Q is 3 by 4. Okay, now for the second part, use substitution, or otherwise we have to solve this equation. Okay, that's pretty easy. Let me use this substitution. X power 1 by 3 is u. So we have 4u plus u square plus 3 equals to 0. Rearrange it. U square plus 4u plus 3 is equals to 0. The quadratic equation, 1 times 3 is 3. U square plus u plus 3u plus 3 is equals to 0. U is common, u plus 1. Plus 3 is common, u plus 1, u plus 1, yeah, equals to 0. So the factors are u plus 1 and u plus 3. equals to 0. Now we have two values of u. From here u equals to -1 and u is equals to -3, right? Now let me substitute u back, that is 1 by 3. Okay, so we can say that x power 1 by 3 is equals to negative of 1, right? And we can say x power 1 by 3 is equals to negative of 3. Okay, so to solve for x, we have to taking cube on both sides, -1 whole cube, and x is equals to -3 whole cube. So here x is equals to -1 and x is equals to negative of 27. These are the two values of x. Yes. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.